Very pleased to introduce our second speaker for this session, Hayley Trower, who's speaking about using Zygonic theory to model expectations in repeated melodic stimuli. Very nice.
Thank you. So my name's Hayley, and I'm talking to you about Zygonic theory a little bit and expectations. As Joni Mitchell so elegantly puts it, songs are like tattoos. They stay with us for life. They're deeply ingrained and they get under the skin. And a favourite piece of music of mine is Blue by Joni Mitchell. And I must have listened to it hundreds of times. For me, it has these magic, aesthetically beautiful moments of expressivity that I anticipate, and I savour that anticipation every time I listen to it. And it's not the memories that might be associated, it's the intra-musical structure, so the way the notes are positioned next to each other in a melodic or rhythmic way. And I'm sure that everyone else in this room has exactly the same experience with pieces of music that they love. And this is a phenomenon or an experience that spurs my research. How is it that we can repeatedly be emotionally engaged by expressive moments in piece of music, even when we've heard it dozens or even hundreds of times? And it seems the answer lies in our human survival instinct to predict the future based on the past. As David Huron puts it, a cook expects a broth to taste a certain way, a pedestrian expects traffic to move when the light turns green, and a poker player expects an opponent to bluff. And of course the same goes for music, whether we're listening to Joni Mitchell or Bach or Taylor Swift. Music takes us on a narrative of predictability and surprise that draws us in again and again. The study of expectation in music has received decades of attention, particularly since the work of Leonard Meyer in the 50s. Very broadly speaking, he proposed that during music listening, the mind generates non-conscious expectations about the future based on what's been heard before. And it's the disruption of these expectations that leads to an emotional or aesthetic response. Theoretical work since then raises the question, how does this work if we know what's coming next? So there are a number of studies and cognitive models of musical understanding that look into this, and they all regard expectations as a foundation for understanding how we make sense of music. And I'll talk a little bit about Zygonic theory and how this fits in. So, Zygonic theory proposes that expectations stem from three sources. The first is musical structures that are currently in train, so whatever we're listening to at that very moment. Within this category, expectations can stem from patterns arising within groups of notes and occurring between groups of notes. These are referred to, as other researchers do, as dynamic expectations, which are ever-evolving, flexible expectations. And they operate in our working memory. The second two sources of expectation stem from previously heard musical structures. And these can be classified as schematic expectations and veridical expectations. And schematic expectations are long-term, deeply ingrained expectations weighted by probability about pitch relationships or other things, musical rules, trends and tendencies, so the most commonly occurring musical features. And they give us a general indication about what might come next. And veridical expectations are specific memories for pieces of music or phrases. So these three processes operate in parallel to a varying degree depending on how familiar we are with a piece of music. With this in mind, there are two aims to my research. The first is to quantify this relationship between these expectational forces. I've collected some experimental data, and I will use this to model how expectations change over time through the lens of Zygonic theory. The second aim is to examine this from a developmental perspective. I want to know what's the nature of these expectations. Are they innate? At what age do they emerge? And how does this relate to our aesthetic relationship or engagement with music? So I'll talk. The data collection is complete, but the analysis and the modelling is still very much underway, and hopefully it's not too far in the future, but at the moment there's still a lot to be done. So I'll talk a bit about my method, collecting the data, and some preliminary analyses that I've only put together in the last week. So participants attended 2 sessions separated by 1 week. In each session, they were presented with the same stimulus 4 times, so they heard the same thing 8 times overall. It's a 26-note piano melody made up of repeating patterns of notes and transposed patterns of transposed phrases. It's played to the participants at 40 BPM, beats per minute, which is quite slow because they were providing note-by-note expectancy ratings by moving their finger along a touch-sensitive linear MIDI controller that's connected to a laptop. So the controller acted as a scale that ranged from very unexpected on the left to very expected on the right. Oh, and the participants were split into 6 age categories: age 6 to 7, 8 to 9, 10 to 12, 13 to 14, 15 to 16, and 17 plus. So first, I'd like to show you how the adults responded to the repeated stimulus exposure, and then I'll present some bar charts that compare some age group means. So this graph shows adults' mean note-by-note expectancy ratings for 4 exposures of the stimulus during the first session. The y-axis represents the expectedness, which ranges from 0, very unexpected, to 127, which is very expected. And the x-axis shows pitches 2 to 26. So you can see that the blue line, which is the first exposure, and then the yellow line is the second exposure. So you can see that the pattern of expectation is the same. This, to me, represents the schematic expectations. But as participants hear the stimulus again, their veridical expectations are kicking in. This shows a sense of growing familiarity. And the same again with the second week. It's the same patterns. When you put the 2 weeks together, after 1 week's rest, it's a bit of a blur of lines, but after 1 week's gap, the veridical expectations sort of were reset, but then they kick in much more quickly after the second hearing. But anyway, this is a baseline from which I want to compare the children's ratings. So these data sort of support the theory that there are different expectational forces that change systematically over time. And this is, so let's move on to some mean bar charts. So I first conducted a repeated measures ANOVA, and I found a significant interaction between age category and exposure for every age category except for the youngest, age 6 to 7. To get a deeper understanding, I then conduct a univariate ANOVA for each exposure. So these charts show children's mean expectancy ratings for the second session, so the final 4 exposures. In exposure 5, there were no significant differences between age group. This suggests that, they were all responding similarly. bearing in mind that these are means, so you can't really get any idea of schematic expectations from this. This is probably more, more showing us more about the veridical expectations, so the overall expectedness. In exposure 6, age group 6 to 7 were significantly different from the other 4 age groups that are in purple, so age 10 to 12, 13 to 14, 15 to 16 and 17 plus, and the same again for exposure 7. And for the final exposure, the youngest children were significantly different from all other age categories. So the youngest age group are responding differently to repetition compared to other age groups. This could imply that their schematic and dynamic expectations are maintaining a larger share of their cognitive resources. Maybe they're focusing less on the bigger picture, and maybe they're listening more to the within-group patterns that are currently in train, that they're currently listening to. And this could also be constraints on working memory, which might develop as they get older. So this is just a snapshot, and there's lots more to come. But in summary, these data support the theory that there are different expectational forces that change systematically over time, and there is this is affected by age. By modelling these data using Zygonic theory, I hope to look at how recency, frequency, within-group patterns and between-group repetition affect the expectations of people in different age groups. Thank you.
Thank you for this fantastic talk. Are there some questions?
Great. Thanks. Great talk, thank you. I just wondered why you decided to break age down into categories rather than treating it as a continuous variable.
It's probably time constraints for getting something together for this presentation, but that's something that I'll be looking at as a continuous variable. And there are also other things like the amount of time that they've been playing an instrument as well, which I would like to look at as continuous variables as well.
Great.
So, yeah, thank you.
Thank you. I was wondering if you also have likability ratings or ratings of pleasure.
No, it's not something that I was able to do. I did give every participant a questionnaire, so I know I asked them how long they've been playing an instrument, how often they listen to music of their own choice, what sort of music they listen to, so some idea of maybe their musical behaviours, but this might just be something that I can look at qualitatively alongside the quantitative stuff.
It would be interesting to see if they kind of like the pieces more with increasing exposures, but then if it hits this maximum and then goes down again, like this inverted U-shape function, would be nice to see. Maybe it's something to consider for future studies.
Yeah, it's a good idea.
Thanks.
Thanks for your talk. Kind of following on from that, I was wondering if you collected information of what type of music they listened to and then what the stimulus was. Was it just random notes, or maybe was it based on a classical music line or a pop music line, and if that influenced how much they expected?
Mm-hmm. So the stimulus that I used in this experiment?
Yeah, and what they listened to.
Okay, so the stimulus is not, it's sort of genre neutral.
Okay.
So it's, I forgot to put a slide up showing the melody, but it's just a very basic piano melody that consists of repeating patterns of groups of sort of 4 to 6 notes. So it's, yeah, not really any genre.
Okay.
So Yeah.
Thank you.
Thank you.
Thanks for the great talk. I'd like to ask if you had taken into account the memory. You did a break of a week where the listeners were away from the stimulus. Maybe there was some group that had learned the melody by heart and knew very well what to expect. What would the results be?
Well, I think you see this in the adults group in that the first time they hear the melody again in the second week, the expectedness increases very quickly halfway through the hearing of the first melody. And I think this is also related to age. So the older the participants are, the more quickly they remember that they're hearing the same thing. Yeah.
And maybe if their ability to remember, every person doesn't have the same skill to recall and put in their mind store something, might be an interesting factor too.
Yeah, and also I think whether or not they're a musician probably impacts that as well. So yes, good point.
Thank you.
Thank you.
Okay, I think we need to move on to the next part, but thank you very much.
Thank you.